Okay, let's begin. So the name of the class is Introduction to Algebra for Math Competitions, and I'm your instructor, Shreyas Shrivastava. If you have any questions, please message me in the message box or email me at shreyasshrivastava@alphademic.org. Please keep your mic muted. After each topic, I'll present some questions to test your understanding and then discuss the solutions. For those who find the questions too easy, there will be some challenge questions in the end. Most importantly, have fun. I'll try my best to make the class fun and understandable, but I'm not perfect. So if you see any mistakes, feel free to point them out. You can also review the session at Alphademic's YouTube channel. And also please subscribe. Okay, so this week's topics are quadratics, part 2, graphing quadratics, more inequalities with quadratics, and then some challenge questions. This lesson was prepared with the help of the Introduction to Algebra book from AOPS. Completing the square. This is the process of adding a number to a quadratic in hopes of making it a perfect square. Keep in mind, a plus b whole squared is equal to a squared plus b squared plus 2ab, and a minus b squared is a squared plus b squared minus 2ab when you do these completing the square problems. So here's an example of using completing the square. Find all x such that x squared plus 8x minus 14 is equal to 0. So we can complete the square, and you see the x squared plus 8x term. So you can write that as x plus 4 whole squared, because that's going to be x plus 4 whole squared is just going to be x squared plus 8x plus 16. So we add 16, so it's going to become, add 16 to both sides, it's going to become x plus 4 whole squared is equal to 30. And if you take the square root of both sides, you're going to get x plus 4 is equal to square root of 30. So x is equal to negative 4 plus root 30 or negative 4 minus root 30. So those are your choices. All right, here's another example. Solve for all x such that 3x squared plus 12x plus 1 is equal to 0. You divide both sides by 3, and you're going to get x squared plus 4x plus 1/3 is equal to 0. And you see this x squared plus 4x term, and you can write that as x plus 2 whole squared. And you add 4 to both sides, so this is going to be like negative 1/3. And you can add 4 to both sides, like that kind of, if you do that, and then with the 4x term. So you're going to get x plus 2 whole squared minus 11/3 is equal to 0, which is essentially what I wrote here. So x plus 2 is equal to the square root of 11 by 3. And our answer will be similar to above. There's going to be two possible solutions. Find a and c such that x plus a squared is equal to x squared plus 6x plus c. So we know by a plus b squared that 6x will be equal to 2xa, because x plus a whole squared is x squared plus a squared plus 2ax, which is right here. So a is going to be equal to 3. And we also know c is equal to a squared, because x squared plus a squared plus 2ax again. So c squared is equal to a squared, or 9 in this case. Right. The quadratic formula. Now that we have developed some techniques to solve these quadratics, what will you do if none of those techniques apply? The technique we use is called the quadratic formula. This is probably the slowest technique, so don't resort to this always unless like you don't have any other choice, like completing the square doesn't work or other techniques don't work. But it can also tell us some interesting stuff. Deriving it. Okay, so let there be some quadratic ax squared plus bx plus c, and you want to find the roots. We can use the completing the square technique, and you divide a from both sides, and you're going to get x squared plus b over ax plus c over a. And then if you use completed the square, you're going to get x plus b over 2a whole squared plus c over a is equal to b over 2a whole squared. And if you simplify the terms and you x are the roots and a comma b comma c are the coefficients in this order, you're going to get this formula, which you should definitely memorize. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. This is a really powerful formula, and there's lots of interesting properties about them. First, there's the discriminant. So the discriminant is kind of like, wait. The discriminant is this term right here. Right here, that's a discriminant. Like the square, like b squared minus 4ac. That's your discriminant. And what the discriminant tells you is if it's equal to 0, right, then you have a double root. So that means one root is repeated twice. So like it's going to be in the form like x plus a whole squared. That's what a double root means. And if it's less than 0, so b squared minus 4ac is less than 0, then you're taking the square root of a negative number, which means your roots are not real. They're like complex. And if they're greater than 0, then both your roots are real. That's all they tell you. All right, here's some examples using the quadratic formula. Ax squared minus 5x plus 6 has a double root. Find a. This means the square root of b squared minus 4ac is equal to 0, or b squared is equal to 4ac. So 25 is equal to 4 times 6 times a, or a is equal to 25 over 4. Okay, now we're going to use the quadratic formula here. Find the roots of the quadratic x squared plus x plus 11 is equal to 0. So we use the quadratic formula. You're going to get minus 1 plus or minus the square root of 1. So b squared minus 4ac. So your roots are going to be in this form. Minus 1 plus or minus the square root of b squared, which is going to be 1 squared, minus 4ac. So 4 times 11 times 1. And your roots are not going to be real because it's the square root of 1 minus 44, which is square root of negative 43. So your roots are going to be like 43i, like negative 1 plus or minus 43i over 2. All right, here's some practice problems. I'll give you guys 2 minutes to work on them. Okay, let's discuss them. So the first question says, find all m for which the roots of 2x squared minus mx minus 8 is equal to 0, differ by m minus 1. This is a problem from HMMT, which is a pretty hard competition. We use the quadratic formula, and we can write this as m minus b, so m plus or minus the square root of b squared, which will be m squared in this case, minus 4ac, which will be negative 4 times negative 8 times 2. So that will be, plus 64. And then all over 2a, so that's just going to be 4. So that's our roots. M plus the square root of m squared plus 64, and m minus the square root of m squared plus 64. So if we take the difference of both of them, if we write the difference, it's going to be like m plus the square root of m squared plus 64 minus m minus the square root of m squared plus 64. Maybe this should say 4. So if you take their difference, the m cancels out. So this m cancels out with this. And this is going to become 2 times the square root of m squared plus 64 over 4. So it's just going to be, the square root m squared plus 64 all over 2. That's the difference of our two roots. And this is equal to m minus 1. Now it's a simple quadratic. We can simply just multiply 2 to both sides and then square them. So it's going to be the m squared plus 64, if we square both sides after multiplying 2, is equal to 2m minus 2 whole squared. Or we can just write that as 4m squared plus 4 minus 8m. Then you can simplify the terms. You're going to get 3m squared minus 8m minus 60. And then you can use the quadratic formula, or you can factor them, I'm pretty sure. I think we can do. I'm just going to use the quadratic formula to show it off. Okay. So it's just going to be a plus or minus the square root of 64 plus 4ac in this case, because this is negative, so it's plus 720 all over 6. And so you get the square root of 784, which is 28. So it's just going to be 8 plus or minus 28 over 6. So our answer should be 6. So 6, and then 8 minus 28 over 6, which is negative 10 over 3. So those are our possible values. 6 and negative 10 over 3. All right. Find the minimum value of x squared plus 10x minus 7. This question, what you do is you can complete the square. So if we can write this as x plus 5 squared. X plus 5 squared, and then there's a minus 7, so we're kind of adding 25 to both sides. So it's like this becomes minus 32. So that's our expression, x plus 5 squared minus 32. We can double check that because x squared plus 10x plus 25 minus 32 is that expression. Now we're going to talk about this later, but there's like a trivial inequality which states that for any value x that's real, x squared is always greater than equal to 0. It's pretty easy to figure out. So in this case, the minimum value of this will be 0. The minimum value of this is 0. So it's just going to be 0 minus 32 or negative 32. So that's our answer. Find the sum of the squares of the roots of the equation 3x squared minus 5x plus 8. Okay, so we can use Vieta's formulas here. You know the sum of the roots is minus b by a. So minus b by a is just going to be 5 over 3. So we know a plus b is equal to 5 over 3. And the sum of the square of the roots will be a plus b squared. It'll be a plus b squared minus 2ab. That's going to be a squared plus b squared. And we can use Vieta's again. And you know ab, the product of the roots will be 8 over 3. We talked about Vieta's, I think, last week. So if you guys don't remember, you can look back on it. So AB is equal to 8 over 3. So that, and A plus B is 5 over 3. So 5 over 3 squared is 25 over 9. And then minus 2 times 8 over 3. So 16 over 3. And this is just going to be 25 minus 48 over 9, which is just going to be negative 24. Sorry, negative 7. Negative 23 over 9. Okay, graphing quadratics. To understand graphing quadratics, you want to first like memorize essentially the graph of y is equal to x squared, because most of the quadratics are like a shift of y is equal to x squared, or like a dilation of it in a way. So the graph of y is equal to x squared, you can simply plot 0, 0, and then 1, 1's here, and then 2, 4. So it's gonna be like no. It's gonna be something like a curve this way, and then a curve up like this. It's kind of like that. It's kind of how it looks. It's gonna keep on going. It's like same across the y-axis, so like you can reflect this over the y-axis, it's gonna get the exact same graph. So that's y is equal to x squared. The standard formula of a parabola is a times x minus h squared plus k. And to figure out the graph of it, we can compare it to y is equal to x squared. When a becomes larger, the graph of the parabola becomes more compact. So by that I mean, if y is equal to x squared was like this, it's going to become more like this. So more compact, because it's going to reach higher values much faster. And if a is smaller, the graph will become more wide, because the values it's going to take much longer to reach the values that y is equal to x squared was able to reach much faster. All k does is shift the function vertically by k units. So if we had, instead of x squared, we had x squared plus 2, we would simply just shift it up 2 units. So if this was y is equal to x squared, it would become 2 units up. So kind of like this. That's what happens if you shift it up 2 units. That's all k does. And as for h, we know that at this point, the function reaches its minimum. So because by the trivial inequality, the minimum value of the function will be at this point when this is equal to 0. So it's either going to reach its minimum or its maximum possibly, depending on the h. So when we draw our parabola, it will reach its min or max at this point. And this point, h comma k, is known as the axis of symmetry, because that's the point that goes directly through the middle of the parabola. If our quadratic is ax squared plus bx plus c, then our point where the function has its axis of symmetry is at negative b by 2a. That's the x-coordinate of the axis of symmetry. If x is equal to y squared, then the function, the function opens to the right instead. So if y was equal to x squared, it would be kind of like this. And if it was like x is equal to y squared, it's going to open kind of like that. So that's the difference. But they both have like the same general shape. It's just one is like rotated in a way. And the function can be written as a times y minus k squared plus h. Notice how the k and the h get reversed in this case. So if the axis of symmetry is 2 comma 6, then instead of y minus 2 whole squared, it's y minus 6 whole squared plus 2. That's your equation in that case. So it's kind of important to remember that for if x is equal to y squared, any function like that. Okay, here's an example. Graph x squared plus 4x minus 5. So you first want to determine your axis of symmetry because that's where like the function it reaches its like middle point or like max or min. So in our case, it's going to be minus b over 2a, which is negative 4 over 2a, which is 2, which is at negative 2. So at negative 2 comma, so see negative 2, that's our x coordinate, comma 4 plus minus 5 minus 8, which is just going to be negative 9. So comma negative 9. Okay, so it'll be kind of like this. Let's just put it here. That's our axis of symmetry. So we can kind of like draw. So our parabola is going to be equal on both sides, if you think about it. And then since there's no a, it's going to be the same general shape as y is equal to x squared. And we know, so we can simply just graph it kind of like this. Our parabola is going to be something like that. It has the same general shape as y is equal to x squared, but it has a different axis of symmetry, and there's a shift in the y direction. The graph of a circle can be written as x minus a squared plus y minus b squared is equal to k squared, where a comma b is the center and k is the radius of the circle. And the radius has to be positive, so k is positive. The completing the square technique is really useful when solving for the equations of these circles. Here's an example. X squared, graph x squared plus y squared minus 10x plus 47 is equal to 20. This is going to be x minus 5. We can use completing the square, so it's going to be x minus 5 squared and plus y squared is equal to negative 27 plus 25. Wait. I think this should be 45. Let me change this. All right. If that's 44, then this is negative 24 plus 25. So it's going to be 1. So that's our equation. Our equation is x minus 5 squared plus y squared is equal to 1. So our center is going to be 5, comma 0. And then our radius is 1. So it's going to go like this. This should have said 44. I'm pretty sure. I just wrote that wrong. Okay. Graph 2y squared minus 4y plus 4. Graph x squared plus 2x plus y squared minus 4y minus 11 is equal to 0. And find the vertex of the equation 3x squared minus 11x plus 12. I'll give you guys 3 minutes to work on them. All right, let's discuss them. So the first question says graph 2x squared minus 4x plus 4. So I think this is supposed to say x. So I can do both actually. So if we graph it, we're gonna look for the radical on the axis of symmetry, and that's gonna be minus b over 2a. So that's gonna be 4 over 4, which is gonna be equal to 1. So like 1 comma 6 minus 4, which is 1 comma 2. That's our axis of symmetry. Now we can just look for another point, which would help a lot. And let's just look at like 2, for example. And this is just going to be 8 minus 8 plus 4. So it's just 2 comma 4. So the general shape's going to be something like this. It's going to be like this, and then it goes up like that. That's kind of how our graph should look. And if it was y, you would use a similar technique, but it would simply just open towards the right in this case. So it would kind of be like your axis will be at like 1, and you're going to be kind of going like this. That's kind of how it look. Graph x squared plus 2x plus y squared minus 4y minus 11 is equal to 0. This can be written as x plus 1 squared plus y minus 2 squared and then is equal to 11 plus 2 squared plus 1 squared, which will be 16. So our radius is going to be 4, since the square root of 16 is 4, and our center is going to be negative 1 comma 2. So it's going to be here. I'm not going to go like kind of like this. Something like that. That's kind of how a circle should look. Find the vertex of the equation 3x squared minus 11x plus 12. So our vertex is going to be in minus b over 2a, which will be 11 over 6. That's our x coordinate. And our y coordinate is just going to be, we plug this in, so we're going to get 121 over 36 times 3, which is 121 over 12 minus 121 over 6 plus 12. So this is just going to be negative 121 over 12 plus 12. And that's just going to be 144 minus 121. So 144 minus 121 over 12, or 23 over 12. So it's going to be 11 comma 6 and 23 over 12. That's our vertex. Or you could say our axis of symmetry is at x is equal to 11 over 6. Quadratic inequalities. When graphing factored inequalities, you have to look at each factor separately. When you have parabolas, you can use similar techniques like last week, but the region is either inside the parabola or outside the parabola. So it's kind of like with the line, it's like above the line or below the line. Instead, it's like underneath the parabola or around the parabola or inside the parabola. Example: find x such that x minus 2 times x minus 5 is greater than 0. Find all x. So you want both of them to multiply to be positive, which means that either both of them are negative or both of them are positive. You can't have one of them is negative, one of them is positive, and they can also be 0. So you want to find first. Let's look at when they're both positive. both of them are going to be positive when x is greater than 5. Like this one's going to be greater than 5 when x is greater than 5, and this one's going to be greater than 0 when x is greater than 2. So clearly, our case when both of them are positive is when x is greater than 5. Now, if they're both negative, that means either x is less than 2 for this one, or x is less than 5. And for both of them to be negative, it's going to be when x is less than 2. So that's our solution, when x is less than 2 or x is greater than 5. So we looked at the cases to solve this one. Find r such that 2r squared minus 3r plus 7 is greater than 0. So we can graph this parabola. It's going to be minus b by 2a is the axis of symmetry, which will be 3 over 4. So something like this, somewhere here. So somewhere on this line. And then 3 over 4 is r, so 9 over 16 times 2, 9 over 8 minus 9 over 4 plus 7. And that's just negative 9 over 8 plus 7. And that's just 56 minus 9 over 8. And that's just going to be 47 over 8. So 3/4 comma 47 over 8, which is like approximately 6. So it's going to be somewhere here. So that's our axis of symmetry, or vertex. And then let's look at another point. Let's just look at 1. At 1, it's at 2 minus 3 plus 7, which is 6. So it goes up. Right. It's going to go up. So it's kind of go like this. It's kind of how our graph should go. Now we want to see, is it inside the parabola or outside the parabola? So to do that, we can use similar techniques as last week, and we can simply take 0, 0. Let's just look at that point. At 0, 0 is 7 greater than at x equal to, at r is equal to 0 is 7 greater than or equal to 0, which is true. So that means the outside of the parabola is your shaded region, or the part that satisfies this inequality, this whole area. Anything inside the parabola won't work, or on the parabolas. The trivial inequality. The trivial inequality states x squared is greater than or equal to 0 for all real x. This is true because if x is positive, then x squared is also positive, as positive times positive is also positive. And if x is equal to 0, the inequality is satisfied because 0 times 0 is greater than or equal to 0. And if x is negative, this is also satisfied as negative times negative is positive. This inequality seems pretty useless because it's pretty trivial, but in reality, it's actually really helpful. I've seen this in many proofs mainly. So like this, for example, prove a squared plus b squared all over 2 is greater than or equal to 2 is greater than or equal to ab. So for all real numbers, the trivial inequality only works for all real numbers. Forgot to state that. So we multiply both sides by 2 and we get a squared plus b squared is greater than or equal to 2ab, or a squared minus 2ab plus b squared is greater than or equal to 0, or we can write this as a minus b squared, as we talked about before, and we just want to prove is a minus b squared greater than or equal to 0, which is true by the trivial inequality. Another example, prove that the sum of any positive real number and its reciprocal is greater than or equal to 2. we want to prove, let there be some real number, x. Then we want to prove x plus 1 over x is greater than or equal to 2. Or x squared plus 1 all over x is greater than or equal to 2. Or x squared plus 1 is greater than or equal to 2x. And this can also be written as x squared minus 2x plus 1 is greater than or equal to 0. And finally, we can write this as x minus 1 squared is greater than or equal to 0, which is also true by the trivial inequality. Quadratic optimization. If you want to find the max value of a quadratic or minimum value of a quadratic, recall that this value will only exist at the vertex of the parabola. So, and there's only one of those that work. Because if you look at a parabola, it's going to keep on going downward forever, and it's going to reach its peak at here, or it's going to keep on going up forever and reach its peak here. So it can only have one of the following, a minimum or a maximum, but it can't have both. That's the thing. So that's why quadratic optimization is pretty useful, using those techniques of the vertex. Example, find the minimum value, maximum value of the quadratic, x squared plus 4x plus 5. So if the maximum value exists for this quadratic, it's going to be at the vertex or at the x-coordinate for the axis of symmetry. So if we like find the vertex, we find it's going to be at negative 4 over 2, which is negative 2, comma, negative 2, comma 4 minus 8 plus 5, comma 1. So some people would just say that's your maximum value, but that's actually not correct. Because if we graph this, you're going to notice that at negative 2, comma 1, it's going to be your minimum. You can show that this is the minimum just by taking x equal to 0. You notice that x equal to 0, you get 0, comma 5, which is obviously going to be greater than negative 2, comma 1. So that's your minimum value. There's no maximum value. Because if you take infinity, for example, this is going to be positive infinity. So there's no maximum value for this. That was a trick question. Okay, so here's some questions. I'll give you guys 2 minutes to work on them. I'm going to discuss these because we're running out of time. So maximize the value of the quadratic, negative 4t squared minus 40t minus 36. Since we recognize that this quadratic is always going to be like, it's going to be like kind of like this. It's going to have a maximum value because if we take infinity, this is going to be negative infinity. So it indeed does have a maximum value. And since we have shown that there is a maximum value, we know that the point at which it's going to have its maximum value is at negative b over 2a, which in this case will be 40 over negative 4 times 2, which is negative 8. So that's at t is equal to negative 5. So the maximum value of this quadratic will be at t is equal to negative 5, and that maximum value is going to be negative 4 times 25, so negative 100, plus 200 minus 36, and that's just going to be 64. So our maximum value is 64, and that occurs at t is equal to negative 5. Find the solution to the inequality t squared minus 3t minus 28 is greater than 0. We can factor this as t minus 7 into t plus 4. So if you want this to be greater than 0, either both of them are positive or both of them are negative. For both of them to be negative, you need either t is less than 7 or t is less than negative 4. So that's obvious. Since this one's smaller, it's going to be t is less than negative 4. So all t is less than negative 4 will work. And you also want to look when this is positive. This is positive when t is greater than 7 or t is greater than negative 4. And both of them will be positive when this one is true. Because this one, if it's like negative 3, for example, this is going to stay negative. So as at t is greater than 7, it also works. So that's our solution. T is greater than 7 and t is less than negative 4. Prove b squared plus 4 is greater than or equal to 4b. You can write this as b squared minus 4b plus 4 is greater than or equal to 0. We know that a minus b squared is a squared plus b squared minus 2ab. And so we can recognize that this can be written as b minus 2 squared. By the trivial inequality, this will obviously be greater than 0. Challenge questions. I'm just going to discuss them right away. We don't have enough time. So the first question is find the triples of integers x comma y comma z that satisfy x minus 5 squared plus y minus 2 squared plus z plus 3 squared is equal to 1. So you know by the trivial inequality that all of these are going to be greater than or equal to 0. So it's like 0, 0, 0, but they can all be greater, obviously. So since they sum to 1, one of them is, and they're integers, one of them has to be 1. So only one of them can be 1 in the so like let's just say this one's 1, this is 0, this is 0. Then z is equal to negative 3, y is equal to 2. And if this one's equal to 1, either x minus 5 is equal to 1 or x minus 5 is equal to negative 1. So our case is 4 or 6. So it's 4 comma 2 comma negative 3 or 6 comma 2 comma negative 3. We can use a similar technique for each of them. Set this equal to, like you can set this equal to 1 instead, and this equal to 0, this equal to 0, and you can solve it. We don't have enough time, so you can try this at home. Actually, when we're done. Alright, how many lattice points with integer coordinates does the circle x minus 2 squared plus y plus 1 squared is equal to 25? How many lattice points lie on the circle? And this is from ARMO. So this is also another hard competition. So since they're integers, you want to find like when x squared plus y squared, and let's take a. So like a squared plus b squared is equal to 25. This is going to be either like a is equal to 5 and b is equal to 0, negative 5 comma 0. So that's two of the cases, and you can also flip them around. So you can write it as 0 comma 5 and 0 comma negative 5. And the other possibility is 3 comma 4. So, and any of them can be negative. So you can write it as plus or minus 3, plus or minus 5, or plus or minus 4 comma plus or minus 3. So we have 4 cases here, and then we can essentially take 2 times 2, so another 4 cases here, and 4 more cases here. So you're going to end up with 12 possible lies, points that lie on this circle. You can try this later. Find those 12. Find all values of z such that z to the fourth minus 4z squared plus 3 is equal to 0. Set z squared equal to a, and we're going to get a squared minus 4a plus 3 is equal to 0, or a minus 3 into a minus 1 is equal to 0. I think we did an example like this before, so you should probably be familiar with this type strategy. And then so either a is equal to 3 or a is equal to 1. So if a is equal to 1, z can be plus or minus 1. And if a is equal to 3, z is equal to plus or minus root 3. So we have a total of 4 possible z's. So we're done. Okay, thank you for watching. Remember to check the Alphademic YouTube channel if you'd like to review the session again, because I'm pretty sure that this, like, today what we discussed is pretty important, like graphing quadratics. Quadratic formula is also really important. So I'll see you guys next week.